Hi guys, so this is a video that's going to help you with today's assignment. Yesterday we calculated the volume of a cylinder. It was the first day we did it, and we did a little project where we kind of guessed how many cubic units would take up the space of this can. And so we kind of came up with that it was about like 240 cubic centimeters. And remember, this could also be written as 240 centimeters with a little 3. So that little 3 is going to tell me cubic centimeters. It's always going to be cubic units. All right, so solve problems involving volume of a cylinder. Now, if I look at a cylinder, the cylinder has circular bases, okay, and a curved surface, and it's a three-dimensional object. All right, so let's describe the formula that we found out yesterday. So yesterday we found out that very simply put, the volume of a cylinder can be found by multiplying the area of the base times the height of the cylinder. So let's go ahead and write down area of the base times the height of the cylinder. Okay, now we have to be very careful because the base itself is in the shape of a circle. So that's something that we're going to have to find out. So we kind of need to remember that in order for us to find the area of the base of a cylinder, we would be finding the area of a circle. Now, we recall that the area of a circle is found by doing pi r squared, which is also can be written as pi times radius. And remember that a good approximation of pi is 3.14. So we're going to be using 3.14 for pi times radius. Now, what is a radius? When I look at a circle, the radius is that distance from the center of the circle to touching the circle. So that is what we call r, and that is the radius, or in Spanish, radio. So tenemos que sacar la área de la base. La base de un cilindro es un círculo. So tenemos que saber la área de un círculo, y así es como sacamos la área del círculo. Pi radio al cuadrado, pi por radio. También podemos usar 3.14 como una aproximación de pi. Okay, but how are they going to write the formula for us in the formula chart? So in the formula chart, this is what it looks like. V equals capital B times H. So it is going to be up to us to remember that V stands for volume. Wait, what does capital B stand for? Ah, that one stands for area of the base. And what does H stand for? Well, that one stands for height of the cylinder, right? So the formula that you're going to see on your formula chart is going to be like this. Now, do they give us the area of the base in the picture? No, they usually only give us the radius and the height. So it's going to have to be up to us to find the area of the base. Now, because the base is a circle for a cylinder, I want to practice finding the area of a circle. So just remember that the radius is that distance from the center touching the circle. So if I want to draw a radius right here, I could even draw it like that. That is a radius, okay? And I could say, okay, that's 2 centimeters. Ah, there we go. That's a radius. Now, sometimes we have to be careful because they will purposely give us the diameter. What does a diameter look like? The diameter looks like extending from one end to the other and passing through the center of the circle. Now, this is a diameter. Sometimes they're going to do this for us. And let's say, for example, that they tell us that the diameter is 10 centimeters. But wait a minute, my formula for area of a circle, I need radius. What do? I chop it in half. So I'm going to have to go ahead and do 10 divided by 2. That's going to give me 5. So I chopped it in half. So now I know that from here to here, that's actually 5 centimeters. And if I wanted to use it for my formula, then I would have to use the radius. It's not okay to leave it as 10. Radius squared is not the same as 2 times r. So, for example, let's say 5 times 2, that's 10. But on the other hand, 5 times 5, that's 25. So you always have to chop it in half if they give you the diameter, okay? Let's go ahead and try some examples. So let's practice finding the area. So right here, the area I'm going to say is pi r squared. Now I look at my picture, what do you guys think? Did they give us the radius? Yes, because it's from half all the way over here. So this is actually radius. So I'm going to go ahead and write in 3.14 times 15 times 15. Type it into your calculator. And we get area is equal to 706.5. Now these are feet times feet, so this is going to be feet squared, and that is our area, or I should say approximate area. Okay, now on the other hand, what do you notice is different about this one? Ah, they're giving us a diameter, so what do I have to do? Chop it in half, okay? Si nos dan el diámetro en lugar del radio, lo tengo que cortar a la mitad, okay? So right here, they're giving me a diameter. So 22 divided by 2, that's going to give me 11. Now, 11 would be from here to here. So that right there is the radius. Okay? So when I set up my formula, I am going to say part r squared when I'm finding the area of a circle. So I'm going to go area is equal to 3.14. Now the radius is 11. Don't use the 22. Okay? So I had to chop it in half and find the radius. The radius is 11. El radio es 11. So tengo que poner radio por radio. Tengo que usar el 11, no el 22. Okay, so let's type it into our calculator. 3.14 times 11 times 11. And that is going to give us 379. What happened to my 7? 0.94. And this is area, inches times inches, so inches squared. And that's going to be our approximate area. Okay, so what do you guys think? Do we have to chop the next one in half? Let's see, they gave us the radius. So no, I don't have to chop it in half. I'm just going to go ahead and use my formula, pi r squared. So I'm going to say area equals 3.14 times 9 times 9. And just type it into your calculator. Now, I always have to say it's an approximation because I'm using an approximation of pi. So my answer is always going to be only just an approximation. All right, so the main difference here is that this is the only one in which we had to go ahead and chop it in half. Why did we have to chop it in half? Because they gave us the diameter and I need to know the radius, okay? So be careful when you're doing those kinds of problems. Make sure you're keeping an eye out for what information they're giving you. Okay, so let's try an example where we actually find the volume. Okay, so it says, find the volume of the cylinder. Use 3.14 for pi. Round your answer to the nearest hundredth if necessary. So these are going to be my steps. I see that it's a cylinder. It's three-dimensional. I need to find the volume. Step 1, write the formula. What did we say the formula was for volume of this solid? Volume equals capital B times H. Now wait a minute, what does capital B stand for? That stands for area of the base. What does H stands for? That stands for height of the cylinder. So if I look at my diagram over here, I can see I have a cylinder, but in step 2, I need to find the area of the base. They're not telling me the area of the base. They are telling me the radius, but that's not the area of the base. I have to do work. Find the height of the cylinder. Okay, that one's easy. They do tell me the height. Okay, so I need to find the area of the base. I'm going to draw myself a circle right here. And they gave me the radius, so I have a 7-foot radius. So I need to go ahead and say A equals pi times R times R. So that's going to be A equals 3.14. When I say A, by the way, it means area. Area equals 3.14 times 7 times 7. Type it into your calculator. And we get area equals 153.86 feet squared. Now, this is only just the area of the base. That's what we just found, the area of the base. So this is our capital B. So capital B equals 153.86 feet squared. This is the area of the base, okay? The height of the cylinder, that's easy. That's just the distance from one base to the other. So that's going to be height equals 5 feet. All right, I have exactly what I need. I needed the area of the base. I found it. I needed the height of the cylinder. I found that one. I'm ready to substitute the values. So volume equals area of the base times the height of the cylinder. All right, so now that all that's left to do is multiply that out. Let's go ahead and multiply it out. And we get 769.3. Now this is volume. We are measuring in cubes, cubic units. So this is cubic feet. Has to have like a little exponent right there. And this is only just an approximation because we're using an approximation of pi. So there we go. This is how we find the volume of a cylinder using the formula. Okay? All right, let's go ahead and practice one more. Okay, so example 2, find the volume of the cylinder. Use 3.14 for pi, round your answer to the nearest tenth. Now right away I notice in my picture that this number is not a radius, this is a diameter. So what do I have to do to that one? Chop it in half. I know it's a diameter because it's all the way from one end to the other. So I need to cut it in half, and half of 12, let's see, 12 divided by 2, that's going to give me 6. So that's going to be a 6. So now I know that this circle actually has a radius of 6, okay? 6 centimeters. All right. Let's go ahead and do our step 1, which is to write our formula. So we're trying to find the volume of a cylinder. Volume equals area of the base times the height. So I need to find the area of the base. I need to identify the height of the cylinder. The height of the cylinder is easy to find. It's right there. I didn't have to do any work. But the area of the base, I have to do some work. So I need to find the area of this circle. So area equals pi times r times r. Now thankfully I had a good eye and I knew I had to chop that 12 in half, and so my radius is actually 6. So area is equal to 3.14 times 6 times 6. Let's type it into our calculator. And we get 113.04, and these are centimeters squared. Now that number is only just our area of the base. So now I know that the area of the base is 113.04 centimeters squared. And I know that the height of the cylinder, well, that's 8 centimeters. And so I'm ready to multiply to find the volume, okay? So let's go ahead and multiply the 2. And our volume is approximately 904.32. Now these are cubic units, so centimeters cubed. And we are done. Okay? So let's answer this question. What did you have to do differently on this one, this example compared to example 1? Well, the thing that I had to do differently is I had to chop that diameter in half. So I can say I had to divide the diameter by 2 to get the radius. Okay, so that is the major difference from example 1 to example 2. Since they gave me a diameter, I had to chop it in half to get the radius. All right, you guys, you're ready to do page 1 of your assignment. Remember, you're only responsible for page 1. I'll give you more time on Monday to do page 2. If you're done early, go ahead and work on Alex or missing assignments. I will see you in lab. Okay? Bye, guys.